What up, people of the internet? How's it going, everybody? Welcome to the stream. Welcome, welcome, welcome. It is Monday, November 1, 1851 hours. I hope you guys are having a great day. So in this quick stream, we're going to do a little quick little project recap. We're going to talk about Director D. We're going to talk about what we've been working on. We're going to do a live demonstration of the application itself and how it's working. Show off some of the new features. Ask some questions. Talk some tech. And then bounce. So that's the plan. That's the plan. That's the plan. That's the plan. We're, like I said, it's probably going to be a quick stream. We'll see. We'll see how the live demonstration goes. It might be a total train wreck. So, you know, you never know. You never know. You never know. Like, we're starting from raw VM. Like, I just provisioned them. So, I mean, it has the potential. It has the potential to be exciting. Indeed, 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 indeed. But, anyways. Kim, how are you doing? Hope you had a great day at work. Hope you had a good day at work. How was your Halloween? Do anything fun, exciting, special, otherwise entertaining? Hopefully you did something interesting. I did not. I was at home. I did nothing. I turned off the lights and I hid so that the chillins wouldn't come bother me. That was the plan. The plan was executed successfully. There were kids in the neighborhood. You know, we had trick-or-treaters. They were around. I just didn't have any candy to give them. So the lights were off. That's what we did. But I hope your Halloween was good. Today's stream is, well, at least the beginning of today's stream is probably going to be equal parts interesting and boring. Depends on where you're coming from. But yeah, we're going to talk tech in the beginning. We're going to talk tech. The very, very first thing that we're going to do is talk. Well, like I said in the intro, we're going to talk about Director D and talk about all of the different things we've been working on, show off the application, and show off some of the new features that we're working on. So, yeah, buckle in. Should be a good wild ride. Should be a wild ride. Kind of getting things situated. So first and foremost, one of the big things that we've changed about Director D is that we've actually published a website for directord.com. And we're going to talk a little bit about that and some of the diagrams. But before we jump into that, we're going to do a basic install of Director D across my server in 5 nodes. And then we'll talk about the diagrams, documentation, and such while we're doing the install, which should be pretty quick. So we'll see how it goes. So let's jump over in the terminal and go from there. Yeah? There we are. Here we are, here we are. Let's recenter this. There we go. A little easier to see what we're doing. So we're in our handy dandy little server. I've got my source code on my server. Let's just go ahead and we'll do a quick fetch. Get stash. All right. I still write origin master all the time, even though it's origin main. All right. Here we go. Literally the head of master. So we'll go from there, yeah? So if we jump over into our handy dandy documentation, we can go and scope out what we have for our handy dandy documentation. We can go and scope out what we've got going on here. And Director D has a lot of built-in capabilities, and we're going to use a couple of those to bootstrap our cluster right here. But the very first thing that we're going to do is run the dev install, right? So I'll pull up another tab and we'll go look at the source code. At the bottom of our README here, we actually have like a full-on tutorial which will walk you through the process of installing Director D, right? And we have a virtual environment that's ready to go under opt Director D, bin pip, and we'll install our source code. Yeah. And for the purposes of examples, we'll use the full path. Now there are RPMs we can use. There's also container images we can use, but we're doing it all from Python. So can't spell. There we go. I'm reinstalling everything so that you can see it. My Halloween was great. It was great. It was a good Halloween. Yeah, I basically did nothing. So it was perfect. It was perfect. Stayed in the house and did nothing. So it was quiet. It was quaint. It was lovely. All right, so our source code is installed in our VM. It's not very useful. It's not really doing anything. So let's go and look at our server systemd. Now this is one of the new features that has come about inside of Director D, in that we have a little entry point within Director D itself that will go and install a systemd service unit for Director D, which is awesome, right? So we want access to it. We are the CentOS group, so we're gonna add that as a group, and we're going to install it. Need more sudo. And then it gives you little helpful information, little tidbits, if you will. Install Director D service unit, and something that you need to run in order for this to take effect. Now we can start it. Pretty simple. Let's go check it. Like, we've got a configuration file for Director D in Etsy. Looks pretty stock standard, bare bones, basic with debug enabled. Very cool. And we can then do our Director D, bin, Director D, manage, node, list. List nodes. Sorry. So yeah, within that scope, you can see we have no data found because we have no clients. So let's go add some. Now we can refer back to our documentation here that talks about how we can do native bootstrapping. Oh, like an idiot, I was not on the correct scene, but yeah. I talked through it at least. So here we are. We can do the node list, and we can see that there is no data found. Ta-da. Yeah. So, unlike an idiot, we'll go back to the documentation now. Yeah, like I said, this is a live demonstration, so the live demonstration gods are alive and well, as we can see. So very first thing we need to do is create a Bootstrap file. We need to, the Bootstrap command needs to understand what we're going to do with it. So we're going to use the native bootstrapping that's built into Director D, which uses libssh natively, right? Uses libssh internally within Director D itself to SSH and bootstrap all of our nodes. What's cool about that is that, well, originally when we first started the project and we first added the SSH bootstrap capability, we did so using Paraminko, which worked really well. It worked super well. I was really happy with Paraminko. Unfortunately, we cannot bootstrap a FIPS-enabled environment using Paraminko, or at least not natively, right? So we converted it all to using libssh directly. What that means is that our bootstrap capabilities are now FIPS compatible. So, and not only is it FIPS compatible, it can run inside of a FIPS-enabled environment, but it's also using libraries that are FIPS certified, if you will. So you can use FIPS throughout your entire environment and still bootstrap nodes inside of your cloud, which is super important, especially if you care about FIPS-enabled workloads. So, anyways, that's a new feature inside of Director D. We changed it all over to use libssh, so it could be FIPS compatible, capable, enabled. Anyways, let's do that. So just following the examples inside of our documentation here, we've got a Director D inventory catalog.yaml, right? And that's actually kind of backed up here what we've got going on inside of our README file, which kind of walks you through those first steps. So if we were just to copy and paste this obviously wouldn't work because we don't have the IP addresses of our servers. These are the incorrect addresses. But it gives you an idea of what we need to do. But let's flip over and get our addresses. Right? So my server address is 172.16.27.123. So we'll do a little something with that. Here we are. There's our 123. And now I've got 5 clients, which means I'm going to need 5 host entries. Yep, looks good. Let's go get our addresses. These are our nodes right here. And then we'll go ahead and put those into our Bootstrap file. Da-da-da. 5 hosts. Let's add 5 targets. Spacing. All right. There are 5 targets. The username of my 5 targets, CentOS. Pretty easy. Username of my server, CentOS. Like I said, pretty easy. Flip back over into our handy dandy documentation here. We can look at this and it says we're going to go ahead and run the bootstrap command. Director D, bootstrap, catalog file, and then I'm cropping it here because we're going to run the development bootstrap. So, opt, director D, bin, director D, bootstrap, catalog. The file we want to run, which is our director D catalog. And then we have a second file that has been installed with our application inside our virtual environment. So catalog, opt, director D, share, director D, tools, director D, dev bootstrap zmq.jaml. And with a bit of luck, this will bootstrap all of our environments. Nah, we're not agent forwarding. There we go. All right, so the very first thing it does is going to bootstrap. There we are, back to our handy dandy WSL. So here we are, we can see the bootstrap command. Bootstrap, catalog, director D, catalog to our built-in tools, just like it says inside of our documentation, and we're executing that now. The very first thing it does is bootstrap the server, which we've already installed and done everything for, but it's just going to do it again, because that's what the catalog has been told to do. So while that's installing a bazillion packages and updating things and taking care of everything that we want, let's flip back over into our documentation and talk about some of our diagrams and things like that we've got going on. So, directord.com, like I said, this is a kind of a newish thing that's been going on since we've started doing some more in-depth development of the application itself. And if we take a look at our drivers, we can look at what's going on here, and we've got our 0MQ driver. This is the default driver. This is the driver that we've been using for most of the time so far. We'll open this up in another tab so you can kind of get a better look at the actual diagram itself. But this is pretty much the flow of what happens within the application and how it all works. Right? So the 0MQ stuff, like I said, that's been there for a while. We've been doing the 0MQ stuff for a bit. What's new is the messaging driver. And now this is really cool because the messaging driver basically takes you, it allows Director D to operate using Oslo messaging, which is an OpenStack project, and it's basically an abstraction layer across multiple different messaging brokers, whether that be Cupid or RabbitMQ or Kafka or a whole bunch of other things. So what we've done is we've basically made it so that Director D can use Oslo messaging to interact with a whole bunch of different messaging backends, without having to require you, the operator, or anyone else to run new or different infrastructure. So if we take a look at that image, you can see it looks slightly different than the 0MQ driver, right? Because the 0MQ driver is a direct socket connection to all of the different nodes, right? There's this the Cupid dispatch router, which is what is part of the diagram here. It's the one that we've tested pretty significantly at this point. is here, right? It's a centralized broker, which allows us to interface with all of the nodes over the AMQP, which is awesome. Like I said, awesome. It's an awesome capability, and it provides actually some pretty cool functionality that may be important to some folks and maybe not to others. Like, 0MQ is fast, and we can use libsodium for all of our encryption, which is part of it. It was baked into Directory, so we can do that today. However, libsodium is not is not approved crypto if you're using a FIPS enabled environment, right? So you can't use libsodium in those cases, which is kind of a bummer. I'm not gonna lie, it's kind of a bummer. That's kind of a bummer. But here's the Oslo messaging driver, right? Which means that you can use Cupid, which means that you can do all of your encryption and everything using OpenSSL and approved crypto with Cupid or RabbitMQ or, like I said, Kafka or something else. Anything that's supported by Oslo messaging. So in environments that are requiring FIPS certification, here we are, we're ready to go. We have the capability to support those environments. It's just using the Oslo messaging driver instead of 0MQ. There's actually some ongoing thoughts and some work that's going on behind the scenes to actually make it so that we can use a brokerless system using Cupid, right? Using Proton, so that, again, we can do something that looks a lot like ZMQ, right? That direct socket connection to all of our different nodes, without having to rely on the server in between. It'll make it a lot faster. That said, this architecture is absolutely no slouch, right? Like where we're able to do around 1,000 tasks in about 20 seconds through Directory across a cluster of nodes using the ZMQ driver. We can do the same thing in about 60 seconds using the Oslo messaging driver. Sure, that's 3 times slower, but it's still crazy fast. You're talking about executing, right? Commands in pseudo real time with 0MQ, and pretty damn fast with Oslo messaging. And if you take a look at the driver itself, the status is still in development. We definitely are making things faster as we get better at tuning things and building out the application using this new tool chain. But yes, it's fast, it's efficient, and it can be FIPS certified. So that's important to a lot of folks. That's a big deal to a lot of people. So looking at a couple other things that have changed within the Directory inside of our documentation, we have some more diagrams about some of the high-level design, what the application looks like, what the line protocol looks like, and talking a bit about the management and what it looks like to manage the environment, what your memory footprint could be, should be, and we talk about some of the different storage backends. One of the things that we can do with Directory early on, the storage backend was memory driven, right? We were using a Python manager to effectively construct a dictionary that stayed in memory and stored everything. And that was great. It worked really well, and it's something that we continue to have. However, memory is something that we want to be very efficient with. And so we've actually implemented a couple of different storage drivers as well. One being the disk backend, which builds upon our existing cache system inside of the Directory client, right? And that is now the default storage backend. And then Redis. Now, Redis was just chosen because it was easy to prototype, but the process by which we are using Redis could easily be extended to something like an Elasticsearch. It could be extended to, MongoDB, various different backends. It's just we haven't implemented those yet. There's been no call for it, I should say, but we certainly could implement it if you're interested. Let us know. But anyways, the disk backend is what is now the default. Early on, like I said, the default was memory. Memory is still an option, but disk is our default. And that's going to use the disk cache library inside of Python. and it allows for really, really quick storage, very fast, very efficient storage of all the different attributes inside of Director D. Did it slow things down? Yeah, it did. That's not a lie, right? Memory is going to be faster than disk. That's just a fact of life. But it didn't slow it down significantly enough to warrant us to even think about whether or not it was going to be a good idea, right? We just did it, and the memory efficiency is being, very light with our memory touch is worth, the microseconds we're losing by using the disk cache instead of the memory. So, anyways, that's what's up inside of the storage backends. With those storage backends, another cool feature which we'll show later on when we actually do some demonstrations of commands and things as we go, is the ability to profile, right? So one of the shortcomings that we had with the Director D was that we knew it was fast and we can measure that, but we weren't able to really give you any kind of analysis of what was going on and why. And so now we can actually analyze parents or commands, jobs, right? And we can basically take an orchestration, execute it, run through everything, and then tell us what was the slowest node, what was the fastest node, what was the slowest round trip, the fastest round trip, the average execution time, number of failures, number of jobs, the node count that it was executed against, the total times that it was successful versus the total times it was failed, and then the actual runtime. All of these little, tidbits of information, these metrics, basically provide fantastic insight into what's being run inside of your environment, right? If we take a look at just this example that's in the documentation, this example shows that we ran 1,000 jobs across 6 nodes, right? And we got 6,000 successes, which is great. That's what you'd want to see. The combined execution time across the cluster was 61 seconds, right? But the actual runtime was 18 seconds. And that's because Director D is highly parallelized, right? Parallelized. That'll be a good clip later. Anyways, it's multi-process, right? So it's super asynchronous. So we can run everything across the environment and as fast as humanly possible, or we can do it in very strict ordering. What's neat is that by being able to do asynchronous orchestrations, which we're going to pivot into another new feature, we're basically allowing nodes to be able to do work that takes a long time and then offload and continue doing other work elsewhere, and then come back and finish the work that was done, or the initial work that we were starting. That basically gives us the ability to do all kinds of incredible things, like in an OpenStack environment where you need to do a whole bunch of host prep and a whole bunch of host package installation stuff, and then you need to set up MariaDB, and then you need to see RabbitMQ. And if you follow that ordering, right, host prep, MariaDB, RabbitMQ, and then Keystone, and then Glance, and then Nova, and you keep going down that order, you're doing a lot of waiting, right? Because not every node is going to run Rabbit or Maria and Keystone and Glance and Nova. And then the dependencies of all of those things, they don't all depend on each other, right? So while Keystone may depend on MariaDB, it doesn't depend on RabbitMQ, and while Glance may depend on Keystone, it does depend on RabbitMQ, and so you could basically create a giant dependency tree, which we're actually doing inside of a different project under the Director D organization called Taskcore. But anyways, you could actually create a graph which has all of the dependencies inside of your application that you want to deploy, and Director D can do it in the most efficient manner possible. And the reason it's able to do that is because it is, for lack of a better term, a dumb executor, right? Director D will run what it's been told to do, and it can either block or it can be asynchronous. It doesn't make assumptions. You tell it what to do, and it will do it. So using, like I said, the dependency management and the graph solution outside of Director-D, or by just executing your orchestrations in a particular order, you can make sure that you're doing it in an efficient manner, and you're not waiting on the engine itself to run the workloads. Because as shown inside of our handy-dandy our handy-dandy profiling example here, we can see that 6,000 things done took 18 seconds. That's a lot, especially given that we're running it, across 6 nodes inside of a cloud, right? That's not too many nodes, but I can show you some other metrics later on through the demonstration, which talk about some of the tests we have done so far with Director-D and OpenStack environments. Actually, we'll just talk about it right now because we're still waiting for things. But inside of... Actually, we're not. It's done installing, but we'll keep talking because I can talk until I'm blue in the face. But we did an OpenStack POC with Taskcore. We'll go ahead and pull that up, which is also a part of the Director-D organization on GitHub, right? And so Taskcore is the dependency management and graphing solution that we're using to effectively and efficiently build out applications, right? So inside of this, we were able to build out a 4-node OpenStack Cloud, a 5-node OpenStack Cloud, and a 25-node OpenStack Cloud using cloud infrastructure, right? So cloud and cloud, but it's really basically just for test infrastructure. And what's awesome is that the 4-node infrastructure took around 18 minutes to deploy. That's pretty good. The 6-node infrastructure took around 18 minutes to deploy. Pretty good. The 25-node infrastructure took around 18 minutes to deploy, which is freaking fantastic because 25 nodes is roughly a rack of gear, right? So if you're talking about data center space, you're talking about 25 servers in a rack. We're talking about our POC environment, so it's not super robust. It's not super well built out and huge and everything else that you would expect, but it's fully complete OpenStack environment that's doing all 8 of the core OpenStack services, and it's taking 18 minutes to deploy from 4 nodes to 25 nodes. Let that sink in. That's incredible. It's awesome. It's a game changer when it comes to managing infrastructure at really any scale, right? Because while I don't have 100, 200, 500 servers to test with, if the math holds true, our 25 node test scale should hold true up into about 100 nodes. We don't know where it'll go after that, but at about 100 nodes, we believe that the 6-core, 4 gigs of RAM, 32 gigs of storage, Director-D server should be able to facilitate the connections to all 100 nodes and deploy the same cloud in around 18 minutes. Anyways, it's good times. It could be. Could be. Anyways, these are some of the new features that have been coming up inside of Director-D. And Taskcore is a part of the Director-D GitHub organization, which is here. We have 2 projects at this point, Director-D and Taskcore. Taskcore is the graphing solution. And again, this is built upon TaskFlow, which is an OpenStack project, right? So we're taking an OpenStack library outside of the OpenStack confines, using it within our application, and building out a graphing and dependency management solution, which is able to resolve all of our dependencies and deploy an application efficiently across the cloud. It's very cool. It's very neat. It's potentially game-changing, especially for the organization and the team that I happen to be in. So it could be interesting. Anyways, our application is actually online, and everything is been deployed inside of our cloud. So I'm going to go ahead and switch my scene back over into my handy-dandy little terminal here, and let's talk about it. So new features. inside of Directory, when we used to do a list node, it used to just say the ID, which was the host name, the expired time, and then and that was it. It was pretty basic. The last time we did a demonstration of Directory, I think that was all that we actually showed, was the ID and the expired time. Now, because Directory allows you to run the server with clients of many different versions, the clients, when they check in, they actually will snitch and tell you which version is actually running. So here we are. We can see that, let's go ahead and list again so that you can see the delta between the two lists, right? You can see that the expiry is counting down, which is what we want. After the time has expired, the node will be fenced and then purged from the system if it continues to not check in. So here we are. We can see our nodes. We got 1, 2, 3, 4, 5, and 0. Well, sorry, I should have started at 0 because that's where numbers start. Anyway, 0, 1, 2, 3, 4, and 5. We have 6 nodes. Ta-da! We can see our nodes. So now we can see that it has a version. And you see this big long string at the end. That's because every time that we merge code into Directory inside of the GitHub organization, right? Inside of GitHub, we have our actions, and inside of those actions, I'll go ahead and flip over back to our Directory repository. We have actions, and inside those actions, we're doing all of our gating and our CI testing and everything else. When we merge code, we are actually pushing code to scipy.org here. And so if you use pip install --pre, it'll pull our pre-release code, which is what you see inside of that terminal output, the version with that string. Anyways, it also tells you the host uptime. How long has this VM been online? You can see that I deployed the VM yesterday. And then how long has the agent been online? You can see that the agent has been up for about 8 minutes. What's kind of unique and awesome is that while you should not have machines that have the same host name, it is possible that you will, and you do. But what you will not have is duplicate machine IDs, because that is randomly generated. So the machine ID is now part of the node list output as well as the driver. And while you shouldn't be able to run Directory with multiple drivers, we're listing the drivers so that you know what has been deployed in your environment at a glance. Right? Pretty easy to understand. But these are all really, new or interesting or neat features that we're bringing to you guys from the world of Directory. The world of Directory. We can see the driver, machine ID, agent uptime, host name, version, expiry, and ID. It's very cool. Now, inside of Directory, the execution process has not changed, though we have grouped all of our arguments. So this is like a total nit, like something that only a true nerd would appreciate, or any of that nonsense. But you can see inside of this, we have our positional arguments. Those are always going to be there. And then we have our optional arguments, which are, the version, config file, if you want to change the driver string, identity, and, some debug output. But then we have our server arguments. These are arguments that only pertain to the server itself. And then we have our driver options. And the driver options are actually dynamically generated based on the drivers that exist at the time that you're running this help command. So if we add more drivers, there will be more options, and the options themselves are embedded in the driver code. So it means that in the very near term, it's quite possible for you, the operator, to have your own driver. If you wanted your own driver and you wanted it to run in a certain way, and you didn't want to share with us upstream for some whatever reason, you could create your own driver, and Directory would gladly run with it and provide you the option for that. It's all using Python. It's all using Python's argparse, the standard library. It's very simple, and it's extensible. So it's neat. So the very first thing that we want to do is actually run our echo module. Yeah? Well, let's go ahead and show the exec. Inside of exec, let's go ahead and highlight that a little bit better. Inside of exec, the options are pretty much the same, except for now we have the ability to pull, we have the ability to wait, we have the ability to stream the output, and we have the ability to force asynchronous execution of things, right? Pretty neat. Just as always, if you don't provide a target, all of them will be selected. So if we take a look at our list of nodes, we can actually run our echo command. Yeah. Job received. Let's go ahead and purge our jobs, list our jobs, and we'll rerun echo so that we just have the one job. It doesn't show any of the bootstrap stuff. So here we are. We can see that the echo job needed to create a work directory before it could be run, because echo is a non-built-in. It is a non-built-in component. Lucifer, what's going on? How you doing, brother? Today we're talking tech, so buckle in. It's a nerd stream. But anyways, the very first thing it did was create a work directory. You see we have 6 successes there. Then it adds the component, which, like I said, is not a built-in component. So it needs to copy that component over to the remote node, and then it executes it. The entire time it took to run that, right? We go back to our manage command, take a look at what we have available to us. We can analyze that parent. Yeah? And we can take a look at that. Yeah. And here we can see that the total time it took to create the directory, transfer the file, and execute the echo return was 0.4 seconds. Let's go ahead and round up and just call it half a second. And that's on 6 nodes. 2 jobs, 12 things were done, and the entirety of those things that were done took half a second. Pretty damn fast. Now, you know, you could say, whatever, it's just running echo. It's like basically print hello. Quite literally what it did. If we take a look at the components, director DE, components, echo, it literally is just printing out the arguments. It's nothing special. But that's not the point. It's not the point that it's doing something special. The point is that it's doing it fast. And it's doing all of this stuff fast. So we can actually do something more useful, right? We'll do the same thing, but with the shell command, which is part of the built-ins. Again, looking at the list of jobs, let's clear all this crap and look at the list of jobs again. The built-in itself, well, let's go ahead and we'll do info. Here's the job info. We can actually see this is what the command was. This is what the standard out was. The SHA, the name, the job name, you know, everything that we had going on with the job itself, the 6 nodes it interacted with, the round trip time, and then the execution time. And the execution time was we'll go ahead and round up and call it 2/100ths of a second. Again, that's across the 6 nodes. 2/100ths of a second. for it to run that shell command. Now, that again, you could say, well, that's not very useful, and you'd be right. But host name, we can actually run some legitimate bash. And here's some legitimate bash. Again, you know, the execution time was 2/100ths of a second. Not bad. Not bad. Not bad. So, from here, where do we go from here? Well, inside of Director D, we can actually look at some of those. We can actually do the analyze command across not only the jobs, but also the orchestrations. And I kind of want to talk about some of the neat things you can do inside of orchestrations. So let's actually create an orchestration. So these are the two commands we've just run, echo and hostname. Actually, we'll go ahead and add echo hi too. We'll change hi to hello. That's the extent of an orchestration. We have now written an orchestration. We should all feel very proud of ourselves. So let's go ahead and run it. There it is. And actually, let's go ahead and purge our jobs and we'll rerun it just for shits and grins. And now we can look at our jobs so you can just see what was actually done. Here's the actual orchestration itself that we just did. We'll analyze that parent. Just take that in. It did nothing? Oh, that's because it was actually cached, right? So inside of our execution, inside of our runtime, inside of our clients, we actually run a cache that actually builds upon info. There we are. It actually builds upon this SHA. Right, the SHA-3224. We take the cache of that and the return output of that and create a fingerprint for it and then store that cache on the client. So if that fingerprint has been successful, it won't run it again. Unless we purge the cache or we forcefully tell it to run again, right? Ignore the cache, which we can do. So let's go ahead and rerun the orchestration using our ignore cache. And now we'll take a look at our jobs. And you can see here's where our jobs were first, and they had an execution time of 0 because again it hit that cache and just returned back. It didn't do anything. And here it is again because it ignored the cache and it did it anyways. And it has actual execution time. So we'll analyze that job. And we'll take a look at that as well. So again, just as before, with everything else we had been doing, the total time it took to run the actual runtime of the 3 jobs that ran, or the three jobs inside of our orchestration, which was a total of 18 different interactions, was 2.4 seconds. 2.44, we'll round up and call it 2.5 seconds. Pretty incredible. Pretty incredible. But, you know, if we're looking at our jobs, that's a lot of UUIDs, and it's kind of hard to read if you're looking at that. If you're looking at that and going like, How do I know what ran, where, and why? Can't I name things? Yes, you can. So we'll change our orchestration and add a name to it. And we'll run it again with the ignore cache. Ta-da! We added a name. Now it's easier to understand. And there's a little space in there. So you can see, here's my orchestration. This is what was going on. This is what I did. And you can do your little node info on the job itself. And we can take the parent ID and we can analyze that. And we can see Director D is running as fast as ever. So, what now? What now? Well, we can also name our jobs. And we'll rerun it. Now, when you name your job, naming the job is useful to make, it's so that humans understand what's going on. But Director D is not human. And while naming the parent and changing it in this output is useful, again, for humans, seeing this here with the run and everything else, we still need to know the ID to get basic information. So while we named our job, info, there we go. So while we named our job, which we can actually take a look at and see everything here, it's all part of the job spec. We the job name itself doesn't populate inside of the output here, right? Because we're just naming it for the sake of naming it to help people understand what we're doing, why we're doing it, and where we're doing it. It's not necessarily something that we're going to output to help change the job list or any of that other stuff. So while you can name the job, it has almost no effect, but the parent does, and that's useful again for knowing which orchestrations ran where and why. So let's do something again a little bit more interesting, right? We're going to go ahead and install New Relic. Share to or Director D orchestrations New Relic deploy. So to deploy New Relic, we need a couple of things. We need the environment variable for the New Relic account ID. We need the environment variable for the API key, and then we're going to run the command. Pretty simple. It even gives you the command to set that stuff across your cluster, right? Ta-da and ta-da. Now, while I'm going to do this, I'm not going to show you, so we're going to go ahead and flip it over to the browser. I'm not going to share my keys with you because I'm not a crazy person. So yeah, what do you guys think so far? Is this interesting? Is this something that's you think is cool, or is this just me spouting nonsense on the internet into the void? You let me know, because inquiring minds want to know. So yeah, I'm going to go ahead and grab my New Relic key here, and we'll go from there. No, learning things you didn't know anything about. That's great. That's what it's all about. It's all about learning and learning. Let's see. add more data. Alrighty then. 2 seconds. Still deploying, or actually I'm setting my keys. Account ID. All right, let's flip back into our handy dandy little terminal. All right, so we're going to run this orchestration now that we have set our environment variables. Yep. Let's do it. Now, this is going to take a minute. So if we take a look at this orchestration down here, we can basically watch it do its work. Now, inside of that orchestration, we saw that first thing it did was set the environment variables accordingly, which is what we needed it to do. And then once it got done through doing the environment variables, right, it then pulled down the script from New Relic, ran the install command, which is what they recommend, and runs the New Relic installation process. And so if we take a look at our handy dandy little browser, while the New Relic installation process is executing, eventually we'll have a couple new servers inside of our environment. Looks like the agent is starting up. To protect my key, I'm going to flip over into the browser here. Or actually, I'm going to come back into the chatting. Yep, it's almost done. It's on the last job itself. So we'll just hone in on that guy and we'll do a watch on that. Stream Beats is getting good. All right. All nodes are checking in. Here's our director D 1 through 6. All of the nodes have been checked in, and we can see basically everything looks nice and happy. Little VM, yeah? So what's important about actually all of this, these metrics that we're taking a look at now, is actually what we're going to take a look at is here, we've been running the server now for a little bit of time, and I'm connected to it over SSH, and I've been running these executions or these orchestrations and whatnot, albeit fairly minimal, for a while. But you can actually see the load average of my box never exceeded 0.35. My packets per second received never exceeded 5K. Ingress 5K, egress about, let's round up and call it 2. Memory usage, minuscule. Storage usage, minuscule. CPU usage, minuscule. I mean, there's Director D there. Using very, very few resources. Very few. Now, these metrics are brand new, so we don't have a lot to go off of here. But here we are. We can see that Director D is in the list and ready to roll. Yeah? So let's go ahead and run something that's going to take a little bit of time. We'll actually run just as we had in that documentation early on, where we ran 1,000 tasks across our 6 nodes. We'll run that, which is quite literally right there. This is the comparative orchestration that we'll run for Director D. Now we have to change the path because we're not in the home directory. We are in opt Director D, share Director D, orchestrations, comparison orchestration. And just to prove, these are all of the different orchestrations that we have available to us. Oh, actually, Director D, home, sent to us, Director D, tests, comparison orchestration, orchestrate YAML. All right. We'll get rid of the target, so we're actually running it across every node inside of our environment. And then we'll wait for it to complete. Now, before we run it, we'll give it an overview of what it is, right? It's quite literally just running echo hello world as a shell command 1,000 times. There's 1,001 total lines in that file. So we're just running shell command 1,000 times. Go as fast as possible. And we'll wait for it to be done. Yeah? Flip over into our little WSL. And here we are. We can see that it's waiting for the command to be done. And it gives you a little status indicator, little BSD spinner. Pretty simple, pretty easy to articulate that it's doing something. And now that something is done. I don't know why that moved to the right, but it did. So, that something is done. We can list the job. 1,000 executions. Done. Analyze it. Here we are. 20 seconds. Combined execution time, 66 seconds total. Ran 1,000 jobs. Had 6,000 successes. Not bad. Not bad at all. Not bad at all. So we can run it again. We can run it with stream. We can standard out everything. Here we are with the stream output. Just basically spamming standard out for all the times that it says hello world. This is basically, it's a nice visual representation of what Director D is actually doing. We can take a look at our jobs again. There's our parent ID. Analyze the parent ID. Took 20 seconds. 67 seconds total execution. A lot of that is because we were spamming the hello world out on the standard out, which takes time, but not a big deal. 6,000, 6 nodes, 1,000 jobs. Total time it took 20 seconds. Now, if we do the exact same thing using other tools, it's going to take a lot longer. Which we're not going to do in this stream because we don't need to. We're just talking about what Director D is doing and how it's doing it, why it's doing it, etc. So we've just purged the jobs, everything's out of the queue, and now it's just back to our nodes running at idle, effectively. Let's go ahead and take a look at our browser. Right? We'll take a look at our new Relic. We'll take a look at our nodes. Since our last check-in, I was on the wrong node, our little server here, it's looking pretty much the same, right? As we executed 1,000 jobs across 6 nodes, we still had a high of around 5K ingress and a high of around 2K egress. Memory usage was flat. Storage usage flat. CPU usage had a bit of a spike, but nothing to be worried about. Load average, we did not exceed 0.4. And there we are with Director D showing up in our process list, showing that it's running. Handy dandy. Gotta love monitoring. So yeah, that's what's new inside of Director D. This is what's been going on. This is what we're doing, and this is how we're doing things, which is actually really exciting. It's a lot of fun, and we're able to build out a pretty incredible little application with it's I won't say it's infinitely capable, but it's getting there. It's starting. Inside of our Director D, we also have our tutorials. These are all old, but they are still relevant. Because one of the really cool things that we've done with Director D since we started the application was that we've kept everything pretty much backwards compatible, going back to the very first version of Director D. Now, while the schemas have changed, which means like the server itself is that version of that first version of the server is not going to support what we have today. The components, what we're doing, how we're doing it, that's all backwards compatible. So that's basically allowing us to do very interesting things inside of Director D without having to rewrite the documentation every time we do it. We've kept it API compatible. We've kept it component compatible. We kept the documentation compatible. We kept the CLI compatible. We've extended things. We've enhanced things, but we have not broken anything. The spec that was written when I first started this application is what I am actually adhering to, even still today. It's very cool. So we've got our tutorials. It's all there. We have our library usage, which is kind of new inside of Director D. Allows you to basically write hooks into Director D inside of your own application if you wanted to use it for deployment or management of environments in different ways. We have the service setup, we have the drivers, we have containerization, which we've had for a long time. We have our orchestration syntax, which we talked about and talked about naming jobs and job breakdowns and how we can run it asynchronously and what an actual job consists of. And then we have our analysis, which basically breaks down exactly what we have done this evening, and almost to the letter, right? Here's the documentation. Our analysis of those 1,000 jobs across my virtualized infrastructure running on an old Opteron server took around 20 seconds. The analysis that we did a few weeks back, we clocked in around 19. So, we've got some pretty awesome software, and especially when you start comparing it to what else is out there, where things are taking 15, 20, 30 minutes to run the exact same workload, and we're able to do the exact same thing in 20 seconds. Sammy's scratching himself. So it's compelling. It's compelling, right? This is 949 seconds. The worst time we had was 101, and that's with the in-development messaging driver, which we already know is going to be a little bit slower. So, the analysis is there, the stats are there. Inside of the repository itself, all the tools that we've used to benchmark the application is there. All of the things that we have done today, including the orchestration to deploy new Relic, is there. Let's take a look at the orchestrations. Right, we've got a whole bunch of different things here to help deploy applications or do things, demonstrate what we can do and how we can do it, right? From everything from deploying New Relic to deploying sonar and radar, if you know what those things are. Like even our functional test suite is an orchestration that we are maintaining in our orchestrations repository, which are used in our actions. And when our actions are executed, actually, you can take a look at, looks like we just got a pull request. And as you can see within this orchestration, we can see that it is building a new container image from that pull request right now. Our CI is helping improve this application right now. What looks like Takashi has done. He's got a pull request to clean up some unnecessary characters inside of one of our shell scripts, which is great. And then it runs through all of our different CI, and then it tests all of the different functional things, which are in those orchestrations that I was just showing you. So basically, the application is I won't say it's 100% production ready, battle hardened tool that everybody should use today, but it's definitely capable. So use it. Definitely capable. So yeah, that's that. I think we're done with this part of the stream. So I'm going to change gears. I'm going to shut down this part of it, change the chapters, and we're going to go play some Guardians of the Galaxy here in just a few minutes. So if you're joining us over on the YouTube side, on the Twitch side, or on the Twitter side, just hang out, and we'll be right back.